In this section, we're going to be considering the commutative property. Often it's the case that the names of things in mathematics are more difficult to remember than the idea itself. So we are going to take some time here to look at an example that will hopefully help you to remember what the commutative property is. When you hear the word commutative in mathematics, think about the related word commute and what that means. My brother used to work in San Francisco. He lives in the Central Valley of California, and he had to commute to work. He would go from home to work, and then at the end of the day, he would turn around and go from work to home. Now, it didn't matter which direction he was going. It was the same distance, whether it was home to work or work to home. Order did not matter. The commute was the same length. Given that example, remember that when you hear the word commutative, you should think commute, and that whether you go in this direction or in this direction, the distance or the number associated with that is going to be the same. Let's take a look at some examples in mathematics. In addition, 2 plus 3 is equal to 3 plus 2. These are both equal to 5. That is an example of the commutative property of addition. It doesn't matter what order you add in, if the 2 comes first and the 3 second, or the 3 first and the 2 second. You get the same result. Let's take a look at this with multiplication. 2 times 3 is equal to 3 times 2. Both of these are equal to 6. Here again, the order does not matter. The commutative property has to do with order. Am I going from the Central Valley to San Francisco, or am I going from San Francisco to the Central Valley? The distance is the same either way. So we have a commutative property for addition, and we have a commutative property for multiplication. In general, we could say for the commutative property of addition, A plus B is equal to B plus A. With multiplication, we could say A times B is equal to B times A. The order in which we multiply, the order in which we add does not matter. Let's consider subtraction and division. Let's say we have 10 minus 3 and 3 minus 10. Do these two things give us the same answer? If you think that they do, then you've probably run into trouble with the bank before. If you have $10 in your account and you write out a check for 3, you're okay. You still have $7 left. But if you only have $3 in your account and you write out a check for 10, you're probably going to get a letter from the bank telling you that they've charged you a fee for overdrawing your account. If we were to do this subtraction, this would actually be -7, which would indicate something like you are $7 in debt. This is not good. This is good, if you're talking about money anyway. These two things are not equal, so we do not have a commutative property for subtraction. It does not work for subtraction. How about division? Let's consider 4 divided by 2 and 2 divided by 4. For this example, let's consider food. Let's say pizza. If you take 4 pizzas home and there are 2 people there to eat them, each person gets 2 pizzas. If you take 2 pizzas home and there are 4 people there to eat them, then each person gets 1/2 of a pizza. These two things are not equal. Therefore, we do not have a commutative property of division. Commutation, or switching of order, works in multiplication and it works in addition for real numbers.